Welcome to Module 3. We are still in the Windows Security and Forensic class, and I'm still together with Hasain. I'm glad you're still watching us.
Yeah.
What are we going to cover in this module?
Well, we're going to go through some details about Windows authentication, or authentication components, like our passwords or hashes or Kerberos tickets and so on. So that's basically our agenda for this module.
Okay. Let's talk about the authentication landscape. This will be our first topic, and the breaches. We spoke about breaches. We should always assume the breaches. Why? That's the only way how we can prevent breaches.
Yeah.
When we look historically, I mean, this is straight from the history as well. We used to live once upon a time in a high castle, right? And it used to be, especially coming from Sweden, where everything is in castles. We used to think that living in high places, high buildings, make us more secure. And if you look in the cybersecurity landscape, it's the same. So people think having some sort of security measures implemented make them more secure. But things are changing as it changed in the history as well. Now, if you look again in our slide, you will see that having the long castle is not good enough, because hey, what if a cloud comes on top of it?
Yeah, basically people are moving out of that castle. They're being kept by the walls. I mean, there was just one door. You could control everything going in and out. And now everybody is outside of that castle with the information. They do have access to that information, whether they're inside or outside. So it doesn't really matter if the walls are high enough or the doors are well controlled or not. The information is still there. It's on their laptops or accessible via their laptops or any mobile devices they happen to have. So
most of our attendees or watchers will probably not remember, we used to have one desktop, one phone, and a static desk, unless you were outside in sales.
Yeah.
But today, we have so many other components besides tablets, phones. Everything is up on the cloud, right? Salesforce, Microsoft CRM, Exchange. We used to have Exchange server, now Office 365, SharePoint, or I can count endless applications. So this brings us to another topic where we look at the cyber attack techniques. We have targeting, phishing, pass the hash, custom malware, application exploit. I mean, we can talk all day about this again, but no. What I would like to do is, let's recap all the hashes. Okay, I told everybody that we done it with Milad last year on Defense and Depth course, which I was using many tools to extract the hashes. But if you don't mind, Hasain,
extract and correct.
Can you please tell me how we can extract it? Why? Pass the hash. It's still there. It's still usable. And I'm going to ask you to recommend some prevention tactics as well, not in details, even though many people talked about it. I want to tell you that it's still here. Even when you use Windows 10, if you don't implement the right measures, this can give you some trouble.
That's right.
So how was the pass hash work? How was the pass the hash working?
Well, pass the hash is simply by protocol. So when we mention that it is by protocol, we mean you cannot really get rid of it. This is because you can always use the hash value for that password and inject that value in any Windows system, and that Windows system will be willing to use that as if somebody's typed in the password on the keyboard on that system. So that's why we keep telling it's by protocol. There is really no way to prevent it. If you have the representation of the password, which is your hash, either it's the empty hash or the LM hash. Now, hopefully, we're not using LM hashes anymore. That should belong to the history. But we still have some systems around us that are relying on backward compatibility, so we might need the LM hashes. Now, the LM hash is the weaker version of it, obviously. So if you got LM hashes around in your systems, you should really take care about that problem and try the hardest to get rid of it. It's not about if somebody can crack it, it's just about how short time you have if somebody gets those hashes. Now, anti-hash is a little bit better, but still it is crackable as well. And there are numerous tools that can deal with that. Cane enable, Luft crack, everything that we could use historically, and then there are new tools for doing that as well. We do have rainbow tables, very advanced, pre-calculated password hashes with corresponding passwords that you can use on online sites. So you just upload your hashes and you will get them cracked by somebody else. That's cracking as a service, maybe. I don't know.
Cracking as a service.
Yeah.
Windows as a service, now cracking as a service. That's good.
So, I mean, that community is moving forward as well, and that community is using the gathered effort as well to give that kind of a service. So if somebody has already cracked that password, they will publish it on some database, and then everybody else will get hold of that password again, so, as they present the hash value. So we still have the problem with pass the hash as far as we have Windows single sign-on and the protocols Windows are using. We're going to have that problem left in the system. What we can do, we can try to disable subsystems using those hashes and then try to restrict the use case of the hashes, like we're preventing anti-LM, we're preventing the LM protocol. We using MSChap v2 to make it harder to do network-based pass the hash, or reflection attacks, or there are many names for these type of attacks. And we can start relying on ticket-based authentication systems like Kerberos or federation-based authentication systems.
You gave me lots of cool ideas.
Yeah, which will basically take away the pass the hash situation. If we start using SAML v2 or WS-Fed or anything similar in the federation scenario, then we don't have really the same type of pass the hash problem. You still have to authenticate to your local federation service, and then from there you will get another type of ticket you present to your applications. So applications will not be vulnerable for pass the hash per se.
All right, then quickly, please, even though we've done it before, remind us how we can extract hashes.
Yeah.
Then from there, how we can crack hashes. Demo time.
Yeah. So let's switch over to this guy over here. As said, we've done this before already, but let me just do it again.
I mean, I use different tools. Again, it's been recorded. Please go watch Defense in Depth 8.1 Windows 8.1 security. This will have many similar demos, but Hasain will just remind you how you can actually crack the hashes.
Yeah, this is the classic Mimikatz type of DOM, the secure LSA. And then, as you can see, you can fairly easy do it in those simple steps. And there we go. We do have the hashes for different accounts, either the computer account itself or people logged into this computer, like local users or domain users.
All right, how can we crack it?
Well, cracking, once you have that, then you push it away to some tool that will help you do that. Like the cane enable, for instance. This
the old, but
the very old, still yet very useful tool. We can do LM hashes, NT hashes. We can obviously do anti-LM v2. And this is MSChap v2, basically over the network. We can do a lot of other protocols, as you can see here. These tools are not only bothering about the anti-hashes, they do a lot of other protocols where the same problem exists. So pass the hash, once again, is by protocol rather than by operating system or version of operating system. So this is just a quick one. Another thing we can still do, though, we've been mentioning Kerberos and federation-based or ticket-based authentication. So that's another interesting scenario where we should start looking at what could we do with Kerberos. Is it possible to crack Kerberos tickets, for instance? Do we have the same type of problem with that?
I was going to ask you this question. This is unfair.
Yeah. Well, let us look at this situation.
Because Kerberos is a protocol which is mainly used in any operating system, right?
Yeah.
It's a security standard, and it's a ticketing-based protocol. So how can we crack the tickets?
Yeah, let me just show you a sample for that. Let me just find the right characters in here. So I do have, this is just a command prompt as a regular user on the machine. And I will just issue a command called set SPN and query Active Directory for services that are Active Directory integrated. So the -q, and then I ask for all protocols, all services registered in Active Directory for Kerberos integration. Obviously, I'm logged in as a local user, then I'm not able to browse Active Directory. So I need to be somebody on Active Directory to be able to do that.
I think we go with some hashes.
Yeah, well, let me just do that again. Run as a different user. And I will do SCC demo. Oops.
Forgot the password.
No, it's the keyboard layout that is messing with me a little bit on my computer.
Sorry, we don't have a Swedish
Yeah.
layout here.
Anyways, now I'm running this in another window. Let me just adjust the font for that so you guys can see what I'm doing. I guess this will be a little bit better. And let me just grab the same command again and then do it. There we go. So if I just go ahead and query Active Directory about all registered services for Kerberos authentication, these are services registered for Kerberos single sign-on. So I do, hey, tell me all protocols, all service principal names, and there are on different machines, different services that will accept Kerberos as an authentication ticket. Okay. For instance, we can find on SRv3 there are web-based service. So if you access SRv3 with HTTP or HTTPS as a protocol, then it's possible to perform a single sign-on on that web application. And we know that there are terminal services, there might be SQL services and so forth, in different applications or different. I see there is a SQL server on this machine as well. So all of that information is accessible and available in our systems. And we can actually, just by being a normal user in Active Directory, start enumerate this type of information. This is all related to authentication and credentials as well. So we don't need to dump memory to start with doing this one. We just need to be a regular user account in the domain. Now, what's more interesting is that if we have a service running as a specific user account, let's look at this one down here. It says intranet-svc, and this is just a user account. This is not a machine. This is not a computer. This one is probably running the intranet web application as the IS user running that application. So looking at those types of accounts, the service accounts we encounter in Active Directory, we know by history that these accounts, once created, they will keep more or less a static password throughout time. So we create these accounts, set a static password on it, and the password will never change. Basically, same password from day one until we change that application, so we remove that account. That makes it a very interesting attack vector. So if I can grab a Kerberos ticket, a service ticket that designated for a user to access that service, that ticket will be encrypted with the service account password. And by knowing that the service account, it doesn't have a dynamic password, it's not changed over time, it's a static password. And if I take care about cracking that Kerberos ticket, I will end up with the account password sooner or later. It's all a matter of time. I need to consume some computer resources and some time on this to get it done. So let's just give you a quick demo about that.
Please.
Yeah. So I will go ahead and tell the system, hey, I would like to get a Kerberos ticket for a certain service. Oops, that was not the right one. Let me just clean it up a little bit. And of course, I'm using PowerShell. So I'm loading an assembly, system identity model, which is a built-in assembly in Windows to deal with identity tickets. And I'm telling it, hey, the argument list is HTTP, and it's not Web01. I will do, let's see, just keep this one. Intra. So I just told it, hey, could you please give me a Kerberos ticket? I want to access a service by HTTP protocol called intranet.sacdemo.com. Remember when we did the search for the services? This is the HTTP /intranet.
Yes.
Okay. So now if I do klist, which is listing my Kerberos tickets, yeah, I see that I do have a Kerberos ticket for that service. So if I now fire up my web browser and go to that service, then there is a ready-to-use Kerberos ticket. Good. So let's see if we go to our demo folder again. Kerberos is a special tool that was made available last summer or last Black Hat.
Black Hat, yes.
Yeah, or I guess it was even more than that, almost a year ago, something like that. Anyways, this...
I mean, I live in Dubai. It's every day summer for us. So. Summer is not the right indication.
So what this one can do, this one can look at Kerberos tickets and start brute forcing the encryption keys. And if you get the encryption key, you get the password. So that's what basically we're looking at. Yeah, so we need to extract the Kerberos tickets, and I just made a simple mimikerb CMD, which will extract the Kerberos tickets. So if I do dir again, these are the Kerberos tickets for this user. So we just extract them from memory and dump them to files, because it's much easier working with them on file. And now our next step will be start cracking these Kerberos tickets. So let's just do this properly. So we do the TGS crack Python script with the word list, and then this is a Python script, so I do py tgs crack, and then I needed a word list, and then the file, which is my Kerberos ticket. So the one with one dash. There we go. So this will work on that file, and working with the word list I made available here until it finds the right password. Now,
I hope you made it easy.
Yeah, we made it a little bit easier, so this works a little bit faster.
1, 2, 3.
So password is APC123. Obviously, it's in the file in our word list. Let's just take a look at that.
Which you can easily grow from the internet.
That's right. So this is the word list. As you see, I had 2 flavors of that, and the other one was the correct password. So now I know that that service account responsible for the intranet service is actually running with this password. Mm-hmm. So that's a very nice way in. I'm just running this all together as a local user. This is a regular user. I don't need to be local admin on any machine for doing this. I can do this all together just as a regular user on a domain joint machine, regular domain user on a domain joint machine. And I can start looking at service accounts with static passwords and start cracking those service account passwords. And most probably those accounts will have more access to other backend components and other components in the domain. So I will most probably end up in a more privileged access level than the one I have already with my original account. So this is what's going on about cracking Kerberos. And now this toolkit provides other means of adjusting the ticket, so you can tell, hey, I'm domain admin now, and then because we can decrypt the ticket, we can change it and reseal it again with the same password, and it looks just perfect. So I can actually elevate my privileges on that application by knowing the password for that service account.
Cool.
So this is just a quick demo about we do have this kind of vulnerability in Kerberos as well, simply because Kerberos is a protocol that uses symmetric encryption. So the same password will be used over and over again, and we can conduct this type of action on it, cracking the password.
All right. Mm-hmm. Okay. Then we said pass the hash, pass the hash, pass the hash.
Yeah.
So we know we can use privilege escalation with credential theft. So if we look quickly in the slide, we will see that the time frame is usually 1 day to 2 days. Mm-hmm. And what happened is it could be sent via phishing attack, but once the credential has been stolen, then you can also search for domain admin and be the domain administrator. I mean, you showed a different way, but now I want to highlight this pass the hash again. Mm-hmm. Why? It's really important. And even though we as security expert or Microsoft as a software and hardware company and many other vendors, they recommend you, hey, you know what, go to the latest, follow the best practices. We know it's not always the best case. And I'm sad to see that I can still see many hotels, many corporations are on Windows XP. Besides talking about the big vulnerabilities there, please demonstrate everybody is watching this, and please make sure this has been watched by many people because it's free. Usually you have to pay lots of money to have Hasain or me in front of you. So please watch it and look at the dangers, how pass the hash can harm your organization. Hasain?
So let's just take it off. Let's do the demo and then we can speak about the details as we go. I just fire up a command prompt. Let me just check the visibility of that. Sorry. Here we go. So who am I again? I'm a local admin guy on this machine, on this computer. Obviously, if I try to reach out to my domain controller, I should have trouble doing that. SRV1 is the domain controller. If I try to reach out to the C dollar share, which is an admin share for the C drive on the domain controller, it will start asking me, hey, what's your username, what's your password? I'm just running as a local admin account on this PC right now. The PC is member of the domain, but I'm just a local user, so I don't have any access.
Admin access.
Yeah. So let's just put this in the background and then go back to Mimikatz. I'm now running Mimikatz, the same Mimikatz we did before, and waiting for an admin or something more privileged to be logged into this machine.
It's like fishing, right? You put the bait and you throw it to the ocean and wait until a fish comes and bites.
That's right. So let's do that again. Somebody with high privs.
Like the administrator?
Yeah, logging in this machine. And then there we are. So we minimize this session. And then we do secure LSA logon passwords. And then we got a little bit in the top. This is the administrator account on the SEC demo logged into SRV1. And this is the NTLM hash for that account. So I take that with me. I just copy the hash, just highlight it and copy it. I got that now. And then go back to Mimikatz and use the same secure LSA, but instead of collecting the logon passwords, I will use the PTH, pass the hash module in it. Okay. So we'll just repeat that, pass the hash, PTH, and it will receive a couple of parameters. For that, I need to provide a / and a user parameter, administrator, and then another / domain, and obviously the domain name, and another / NT LM, and then the NT hash I just kept in the clipboard from the previous step. So once running that, I will receive a new command prompt. Now this command prompt is now loaded with the
goodies.
Yeah, that's the credentials I just injected. That NTLM hash I just injected into the system. So using this one, I do the netuse and then the /SSRV1 /C $. And then obviously I could reach that one. Just to show you the difference between these two guys. This is the one with the admin access privilege, okay? And this is the one, the original one without the admin access privilege. Look, both of them have been running or are running with my local user. This one is a little bit special where I did inject the hashes for the domain admin in memory for the LSA process governing that one, whilst this one is running without those hashes. And this is basically pass the hash. This is how easy it is to perform pass the hash. And then use some credential you grab from off some machine You might use this one on a totally different machine if you would like to. If I suspect that multiple accounts are sharing the same password, I can jump between accounts doing this type of operation as well. It's still called pass the hash, and I don't need to bother about the clear text password anymore. I don't need to crack those hashes. As far as there are protocols willing to use the single sign-on components in Windows based on whatever I'm logged in this session, then pass the hash will work just perfectly. So that you can establish RDP sessions. If RDP single sign-on is enabled, you can access websites, intranet, or so forth if that's enabled for those protocols as well. And of course, you can access file resources and other type of Windows resources as well.
Cool. This is one thing which I want to highlight here. Like, some of you might say, hey, when is the administrator going to log on to this PC? Please don't forget. Usual standard user don't have all these rights. That's why it's so common that if you think it's going to take some time, it might take some time, but the hackers have unlimited times. So as long as...
and it's the case is actually that attackers will do something we call lateral movement. So they will be jumping from one workstation, one server to another until they reach the final destination, which is that's the workstation or the domain admin is, or there is a server admin. So if I take this one, I might take all the backup system, or I take the virtualization system, or the system center management system, or whatever. And then I will be able to get my hands on more important, more precious pieces of the ecosystem in the company. So lateral movement together with pass the hash, two very important components per se, but together it's a very lethal weapon. So you can reuse passwords across multiple machines until you reach your final destination, which is a domain controller, and gaining access and gaining control over that one.
So this was a good summary as well. In summary, what have we covered in this session? So we covered how you can steal hashes, how you can crack hashes, how we can crack Kerberos tickets
as well.
And here's probably 3 important points which I want to mention. 1, you are the weakest point. Humans.
The users. The users are targeted.
I mean,
they are number 1.
We are all users. And we are the number 1 target. So you are the weakest point. We are the weakest point. And start to hack yourself first before you hack someone else. Secondly, you should know your stuff. And I keep telling this. Like, can you imagine you going to a doctor and saying, hey, doctor, I'm sick. Find out what's wrong. He's going to look at you, or she's going to look at you. Excuse me? So you have to specify what your issue is. That's why you have to know your body. Same exists to your network. Know what is in your network. I know some of you work in a huge network like Microsoft. It's really hard to know, but I'm pretty sure you have segmentation. You have jobs.
And speaking about segmentation, we've been speaking a lot about network segmentation. Now, the new things here is that we need to start speaking about credential segmentation, identity segmentation as well. So if you're managing your domain controller using this workstation shouldn't be used for any other type of management purposes, because this is equally important as your domain controller is. So if somebody gets in touch with it, then they are basically in touch with your domain controller the way you do. So we should segment the access not only based on network, we should segment access based on identities as well. That's where we need to go.
And I think Microsoft came with something good, which is RABAC, role-based access control, which or the features for pass to hash in Windows 10. They're all good, but only when you implement it.
And then the whole model with just-in-time access, the new Active Directory, and Windows Server 2016 with the privileged access management models, where you will request access to your elevated privileges, and you will get that access within a certain time frame. If you don't use that access, if you don't acquire your tickets within that time frame, you will not be that domain admin anymore. So all good things coming out. And the other thing we should really recommend here as well is the local admin password system. That was released earlier this year. It was an open source project. Now turn that into a Microsoft product, which is fully supported for enterprises. So start looking at that. That will manage your local admin passwords and give you randomly set local admin passwords with the possibility to read them using a delegation model in Active Directory. So you can still manage and reach out to your machines with those local admin accounts.
I mean, I had this in my summary notes here as well, passwords.
Yeah.
Still today, I ask many people, how long is your password? Please don't answer this to me. Ask this question to yourself. How long is your password and how complex is it? Our demo showed that very clearly that the shorter, the less complex, the easier to hack.
Yeah.
Choice is yours. We will be here. I would like to thank you to Hasain for sharing his expertise. Next module, I'm going to have Raymond with us. And we're going to talk about forensics. You saw how we can attack. We're going to assume attack happens.
Yeah.
Next is how we can find how it was attacked. So thank you very much for watching.
Yeah.
We will be back. Thank you.
Thank you.